So this is a screencast addressing the standard I can derive Snell's law from how some circles appear to travel slower. So this is the simulation that I'm going to talk about in the picture that I have. So it looks like on one side of the line there's an index of refraction that's higher than the other. So it appears like there's smaller circles up here. And here's the picture that I used. Let's see if I can crop this. One sec. So on the bottom there's the bigger circle, which you can fill out by drawing this line of where our light's hitting. And on the top there's a smaller circle because it's lagging behind. So then if you to draw a right angle between here and here, and then a right angle here and here, this length is the same for both of them. In your screencast, you call this a hypotenuse, and then keep that, and then set them equal to each other. So if this is theta 2 and this is theta 1, in some sort of time t, which ends up canceling, this is how far that the light goes, and in some sort of time t that cancels, this is how far the light goes. So the sine of this theta is opposite of our hypotenuse, and the sine of this theta is opposite of our hypotenuse. So sine theta 2 is equal v2 theta 2 or theta t. I was a bit confused until the v's cancel why we were calling them two different v's, because it seemed weird. We spent so much time talking about how they weren't going to travel at different speeds, and then we were calling them different things, but it looks like that was just to keep things consistent. And then sine of theta 2 is equal to v2 times change in t over this hypotenuse, which is the same hypotenuse, and sine theta 1 is this one over this hypotenuse. So then solving for the hypotenuse yields a v2 change in t over sine theta 2, v1 change in t over sine theta 1. And then cancel the t's, and then substitute v is equal to c over the index of refraction. So you have index of refraction 1 and 2 times sine theta 2 sine theta 1, which is Snell's law. So all that this really shows is that just some angle of reflection is, just that angle in is equal to angle out.